In today's lecture, I want to conclude this chapter by talking about the multiplication property. So we already mentioned the multiplication property in the previous lecture, but today I want to go in a little bit more details. So first, I want to remind you about the multiplication properties or property and work out a couple of examples. So this is again the same slide you've seen before. So the multiplication property says that multiplication in the time domain is equal to convolution in the frequency domain, and don't forget about this unit factor, scaling factor, which is 1 over 2 pi. Again, if you're wondering why we have this, is because we're using omega as our frequency. And then in a pictorial way, multiplication, this graph shows this equivalence. So multiplication in the time domain is equal to 1 over 2 pi times convolution in the frequency domain. So for those of you who are curious about where does this property come from, here I have in this slide and the next slide the proof of it. I don't want to go through it now in details, but you can read the proof. And to prove this, we actually walk the inverse way. So we assume that y of t is the inverse transform of 1 over 2 pi x of j omega convoluted with h of j omega, and we want to show that y of t is actually the product. So we want to show that the inverse of the convolution is the product. Similar to the proof of convolution, so the steps are kind of automatic and they just based on exchange of integrals. I don't want to do the details, but you can check them in details at home. So by doing this integral manipulation, you can prove that y of t, which we started by saying that y of t is the Fourier inverse of 1 over 2 pi h convoluted with x. So you will prove that y of t is the product, and therefore we prove the multiplication property. So what I'm more interested here is in how to apply it. So let's work out an example. So the question here is to find the CTFT of y of t, which is equal to sine bt divided by pi t times cosine omega 0 t. So I hope that by now you can immediately see what's going on here. So you have two parts. You have a low pass filter here, and you have cosine omega 0 t that is kind of gonna shift the low pass filter to the frequency to be centered around the frequency omega 0. So in the frequency domain, like I said, the sine bt by pi t is a low pass filter that is depicted here. So maybe if I color it in green, you'll see it better. So x of t is this guy here, and cosine omega 0 of t, I'll color it in blue, is actually two impulses, two delta function, one at omega 0 and one at negative omega 0 with amplitude or magnitude pi. And then to get the y of t in the time domain, what we're gonna get is, or to get the CTFT of y of t in the frequency domain, it's going to be the convolution of these two signals. And again, don't forget about the factor 1 over 2 pi here. Now, the question is, what is this box function convoluted with two impulses going to give me? If you remember, the box function convoluted by the impulse is just going to shift the box to the around where the impulses are positioned. So the convolution of these two signals are gonna give me the following signal here, which is basically a bandpass filter. So it's gonna be the box, one version of the box centered around omega 0, another version of the box centered around omega 0. And the magnitude is 1 over 2 pi because you have to divide by the factor 1 over 2 pi here. And actually, this property works for any signal. So suppose that, or at least for any bandpass signal. So suppose that your signal is in the frequency domain, looks something like this, and you convolve it with something omega 0, where omega 0 is far, so it doesn't intercept. Because I'm just trying to avoid having to
to have an aliasing. So let's suppose that omega 0 is outside of the bandwidth of the signal. So what you're going to do, you're going to get copies of the signals at omega 0 and minus omega 0. And this will actually give you another interpretation of the frequency shift property. So you know that when you multiply x of t by ej omega 0 t, so this is a multiplication, so in the frequency domain, it's going to become a convolution, right? And then, which means that this is going to be a shift. And this brings me to the end of this chapter on CTFT.